Good morning and welcome to Tech Field Days at Cisco Live Barcelona. My name is Chiara Regale. I'm VP of Product at Forwards, and I'm joined this morning by two coworkers, Elyor Khakimov, Manager of System Engineers, and Andreas Voellmy, Software Engineer, sorry. We are delighted to be here. As Tom said, it's been 2 years since our last appearance here, where we launched the company. And in the next hour, we want to show you how we advanced the product so far, and also talk to some customer use cases. So first of all, a few quick facts about us. Who we are, what do we do? Our platform is a network assurance platform through verification that helps managing network in an efficient and more reliable manner. We have our flagship platform called Forward Enterprise that is built on a mathematical and behaviorally accurate model of the network that really helps operators verifying the intent and troubleshoot network problem at speed, end-to-end across network devices. We founded the company back in 2013. We launched the product and the company at the end of 2016. And since then, we've been deployed over tens of thousands of network devices worldwide. Network devices for us are switches, router, load balancer, and firewalls. We also have individual customers that have deployed us over tens of thousands of network devices as well. We are in production, again, worldwide, across the major verticals, including a financial institution, service provider, managed service provider, and enterprises in general. And why are we relevant? Why customers are choosing us is because we are multi-vendor. We can support physical and virtual environments. We play in the private and public cloud, and we have proven to scale in the real customer deployment. So why in the network operation world is there a need for a platform like us that help accelerating operation? Well, what we hear from customer and prospect is that by far, for the majority of the cases, they still have to operate their network manually with a level of abstraction that is not up to date with what the business needs. Every time there is a network to verify, every time there is a change to be applied, every time there is a troubleshooting task, everybody or most of us reverts back to a terminal type of environment, as you see on the left side of the slide. Ping, trace route. There are some tools that help automating these tasks, but are not really multi-vendor, they're not end-to-end, they're not across the plethora of technology that we have today. So where we help is really in giving the level of abstraction that agile business needs today to do their job in a quick, speed manner. What operator would like to do is, I don't care about a specific forwarding table, but I want to know, for instance, if there is a connectivity between sites for specific ports on the firewall. Or I want to know if my production environment is completely isolated from my dev environment. So take a more abstracted level that verifies connectivity and security posture end-to-end. So here's where Forward Enterprise will bring value. And you will see, you'll touch with your eyes during the demos that Elyor and Andreas will give you in a bit. How are we achieving this goal? Well, we take a quick sneak preview on our architecture. The starting point is the collection of devices, configuration, and state of the heterogeneous network we model. And again, networks are switches, routers, load balancers, firewalls, and virtualization devices. We basically read, show configs and state, no data on statistics, no latency. We capture all this information in a snapshot that gets then modeled in a vendor-neutral abstraction. Doesn't understand or doesn't talk the Cisco language, the Juniper language, the Palo Alto language, but is a vendor-agnostic language that allows us to basically trace all the connectivity in the environment.
So you effectively map the vendor-specific data models, if you wish, into some common data models so that you get rid of the multi-language problem.
Spot on, Ivan. In fact, you'll see in the next build that we also talk about a data model, but you're spot on.
And you have read-only access?
Only read-only, exactly. So we don't have probe on the devices. We don't send dummy packets. We are completely non-intrusive to the environment.
And you work both with device configurations as well as with current state.
That's correct.
So you can, for example, I know I'm rushing ahead, but
you
can, for example, predict how a routing protocol would respond to a link failure.
Not in these terms. We have a prediction capability, but at the moment includes an access list on switches and router, firewall rules, and NAT configuration. Layer 3 protocols prediction is something we're thinking of, but not there yet.
But still you are getting the routing table, so
Yes.
you can show end-to-end
Absolutely.
traffic flow, and if there is asymmetric routing, etc.
Absolutely. Absolutely.
But on the current state of the routing table.
That's correct.
Okay.
That's correct. Okay. So once we have this vendor agnostic view, we apply an algorithm that is what determines what creates the mathematical model. This algorithm is called header space analysis because by applying it, we can resonate about all the headers, layer 2, layer 3, and layer 4 headers of packets that traverse our network. The mathematical model is important because we don't give information just on one potential path that the traffic can take, but all the possible combination that a given traffic flow can take. And this will allow us to build in our software an accurate software model of the network.
Sorry for jumping in.
No, it's okay.
You are building all the possible alternate paths based on the current state of the forwarding
That's
table.
right.
So you are dealing with ECMP,
Yes.
but you're not dealing with backup paths.
That's correct.
Okay.
In fact, why not? Maybe use CMP or even weighted ECMP. So you are checking the maybe topology tables as well.
Yeah,
no?
so let me address that backup path. There are some technologies like MPLS with RCPTE where you can establish the primary paths and the bypass path.
And you have both in the LFIP, so you both are there for you to see.
Yes, so
Exactly.
we retrieve all the data, and because we are also retrieving some additional data for state, we can distinguish between which one of the paths are active, which ones are bypass, and therefore backup. And that nature, you can extrapolate that approach to the rest of the technology that we model. And so
as long as the backup path is visible in the forwarding table, you can take care of that.
I would even more generalize, as long as those paths are visible in the forwarding state that we retrieve, then we will be able to show you the details.
Okay.
In fact, maybe not even in the forwarding table. Let's say in the IGRP case, the backup path might be, which we call feasible successor anyway, it may be in the topology table, but not in the forwarding table. So in that case, you can still see that path as well.
Yeah, so let me quickly handle that. Our platform retrieves the forwarding state, right? It looks into RIB, FIB, and it doesn't really matter what control plane and how it established that state in the forwarding table. So in the case of your specific example of EIGRP backup paths, those paths will not be installed in a FIB. They will remain in the control plane.
Unless you enable EIGRP phase 3 route. But
That's right. Right. You're absolutely right.
what about ISAS? Do you support ISAS?
Yes. So
They support anything.
yeah, we
They
support
look into
any routing
FIB.
protocol. Yeah, we support. That's right, Ivan. We support any routing protocol that installs the route.
Because you don't care; they are above you.
Yeah. So we look at the state, and that tells us how network behaves.
Because there are other competitors.
Just a quick one. This is the routing portion. If you have something dynamic, just making a buzzword SD-WAN, yeah. Whenever the state is changing, you can read that out via API maybe, and then put it into your model, yeah? Or how is this working with an SD-WAN environment where you have dynamic paths?
Yeah, currently SD-WAN is not supported in the platform. It's on the roadmap for a later time, but at the moment it's not supported.
Okay, but in general, you could normally, as long as you can read to the controller, you can figure it out and implement it to your model, yeah?
That's right. That's right.
Let's just say that at the moment, probably those APIs don't give them the data they need.
Yeah. So Ivan is right. We read the config and state via CLI. CLI is the common denominator across all the vendors that allow us to gather all the details that we need to build the model.
Yeah, I see the big challenge that more and more, let's say, network devices are going for pretty dynamic path selection, yeah, based on policies, yeah, and that not like we had back in the days, always paths only determined by the routing. Maybe there are some on-top policies like latency, behavior, and things like that. Yeah.
Oh, thanks for mentioning that. How do you handle redirects and shortcuts in DMVPN?
I'll pass it to my technical arm.
Yeah, absolutely. Yeah, so we recently started supporting DMVPN. So I would probably need to refer back to specific implementation of what exactly is done there. So I'd have to defer that to later time, Ivan.
Perfect.
So DM phase 3
Okay.
specifically, he's
Yeah.
Got it.
asking.
Yeah,
We can get back to you on
Yeah.
that.
So
Because the actual forwarding path is below the forwarding table.
Got it. Okay, we'll get back to you shortly.
Don't
on
worry.
that. Thank you. Okay, so in parallel to the mathematical model, we have what we call a normalized data model that allow us to basically make available via very well-defined schema all the config and routing information. Why? Please.
As it says OpenConfig there, and we all know that OpenConfig means what Google needs,
Right.
which covers like 10% of your needs.
Yes.
Are you heavily extending that and augmenting it so that you can fit all your things in?
Hold on. If you don't mind, Ivan, we have a specific session on this.
Sorry?
We'll provide more details.
Okay.
I just want to be sensitive that we can move on and show you the real product. Okay, so this normalized data model that we call the network query engine allow us to expose, again, via well-defined schema, all the information that customer may need. They don't have to spend their time in parsing all this precious data, and they can instead customize dashboard or verification checks that are meaningful for them. So on top of this mathematical model, we build a few applications that can be used via a GUI, a very easy to use interface, or via REST API or GraphQL for the data model. The key applications are forward search, forward verify, behavioral diff, and predict. I'm not spending time on this because you'll see in details during the demo. One last comment on this slide, the platform can be deployed into offerings, on-premises offering, where the end user gets an OVA file to be installed on their environment, or a SaaS model, where the customer just installs a crawler, a Java piece of software that will read the configuration and state, and then the model is taken care of by us in AWS. Okay? Now, let's take a quick view of the use cases. Forward Enterprise has been built to address many, many use cases, but we just selected 2 that are most common across all our customers, and these use cases will be demonstrated by Elyor as well. So the number 1 is the application team self-service that is powered by forward search. What is that? Every time we talk to network engineers, they tell us a lot of time, every day, I receive many tickets from the application teams. Application teams need to be agile, they need to deploy application all the time, but they need information from the network guys. Do I have connectivity to the web server? Do I have connectivity to internet for just specific ports? This question seems very easy to be addressed, but the current network teams don't have the right tool to address these answers at speed. So what we offer here is a self-service portal for the application team, such that they can query themselves simple questions like from IP address to an IP address for specific ports. So application team can get answer quickly without bothering the network guys and go live with their job.
But they are able to do, I didn't get the point. So application team here, are they checking the end-to-end path?
They can verify the end-to-end path themselves, just to verify connectivity and simple security posture. Is my port 80 open? Is my port 443 open or not? Okay.
Effectively, you're removing the level 1 tech.
Right. Yeah. Right. We want to make it easier and make the team more efficient to do their job quickly.
Yeah, and also with the results of your search, they can just copy-paste them into the ticket saying, hey guys, this is wrong. Now
That's
go
right.
fix that.
That's right.
I think we should have Ivan present this.
Next field days. The second and last use case is powered by behavioral diffs and verify. And what it is really a change window assistance, right? Today, networks are very dynamic. They need to change. We need to upgrade a new software version. We need to replace a new piece of hardware. We need to deploy a new technology. And these are very invasive tasks that take a lot of time from the network engineers team. I make a change, then I deploy an army of people that verify if connectivity is fine, if security is not broken, if application reachability is there. Forward Enterprise helps automating and accelerating all these tasks because through behavioral diffs and verify, it's very easy to understand if connectivity is working, if security posture are maintained, and the network is ready to go live the next business days. Okay, so this is my transition slides for Elyor, and Elyor will give you now a demo on what we just learned.
Wonderful.
While he's preparing for
Thank
the
you,
demo,
Chiara.
I just have one more question on OpenConfig.
Yeah.
So effectively, I mean, it would be overpriced, but I could use your product as a nice CLI to OpenConfig gateway and collect data through CLI and extract data in OpenConfig.
Yeah, so we'll see more on that in a little bit. But yeah, you can basically get OpenConfig-like data from our platform from all devices that we support all over, because we've already done that collection.
So a nice data normalization platform.
Yep. Okay. Wonderful. Thank you, Chiara. Hi, my name is Elyor Khakimov. I'm systems engineer at Forward, and together with my colleague Andreas, we'll present you the demo of the platform. So the presentation of the platform will be done using those two use cases that Chiara mentioned earlier, the application team self-service as well as change window assistance. Now, throughout the presentation, I would like you to keep in mind three things. Forward platform operates based on a snapshot. So think of it as an X-ray image of your entire network at any given time. The Forward functionality is based on the data that is collected as part of the snapshot. Now, the snapshot can be collected as frequently as necessary. You can either manually launch the collection through user interface or invoke REST API if you want to integrate to automated workflows. Or you can also schedule, using built-in scheduler, the automated collection.
Just a quick question. How often do you take this
As often as
on default?
Yeah, as often as necessary, there are no defaults. So you will need to set it up. Our most typical use case prompts collection once a day. So
Once a day, yeah.
yeah. Now, the second point to remember here, no live data is analyzed and seen by the Forward platform. So there are no NetFlow, SFlow, there are no fiber taps, no span data captures. Everything is, all the functionality again is based on the data from Snapshot. And the third point, the network that you're about to see is built for demo purposes. It does not contain the actual customer data. All right, let me switch to the. So let me refresh this real quick. All right, what you're looking at right now is a web user interface, and we don't need any thick client or installation of any software. All you need is a browser. Once you log in, you see that we have this demo snapshot already collected, parsed, and processed, and it's ready to be used. I'd like to highlight, well, first of all, let me zoom in just a little bit here. All right, that's a little too much. All right, so I would like to cover a couple of things. Just 1 second here. Out of the way. All right, so Forward platform provides single view of your entire infrastructure, an end-to-end behavioral model. And this is a hybrid infrastructure, right? In this view right now, in this network, we have 7 software and hardware vendors, including hybrid cloud, the private cloud, VMware, NSX, and later on, right here down at the bottom, you see, I will show you in more details how we render VXLAN overlay tunnels. We also have standard typical hardware that is seen in data centers. So routers, switches, firewalls, load balancers. And on top, we have a public cloud, Amazon AWS VPC, that is connected to the main data center using IPsec tunnel. So we draw those two. Now, these devices are linked together in a snapshot, in a topology, using the collected LLDP and CDP data. So in the absence of CDP and LDP data, some devices don't support it, we have link inference or heuristics algorithms that intelligently figure out how things are interconnected.
Like using subnets or things like that.
ARP tables, adjacency, subnets, etc.
Or
Absolutely.
table.
Do you do device discovery, or do I have to tell you where the devices are?
Both. We can do either.
Okay.
All right. So going back to the platform here, let me show you what one of these devices look like. This is Juniper router. And we have collected multiple artifacts. So configuration. Configuration collected tells us how this device should behave. So this is what architect put in as an intention for this network device to operate. And then we have forwarding state, ARP tables, IPv4, MPLS routing tables, etc. These bits of data allow Forward platform to reason about how network devices and network overall actually behaves. So take the config, take the state. So now I would like to simply bring this back up and open up with the first use case, the application team self-service. But before I do that, real quick, I want to just simply show that search capabilities in Forward platform can be roughly split into two facets. One is a free text search. And let me show you how this free text search could help decrease tenfold the amount of time that it took one of our customers to, actually this is a real case, to troubleshoot and remediate the issue that they have seen. So what happened in their environment, they had a bad automation script that was configuring malformed route policy. So think of it, route map. And so what happened is they had to now kill the script. And they found the script very quickly. But it took them roughly 2 weeks, about 2 weeks of engineering time to find all the impacted routers. And there were over 200 of them in the network to find them and remediate and clean up the mess that was caused. In the case of the Ford platform, with the free text search, you can simply type in your search query. And as you can see, it highlights right there in the topology right away. So you can always search for whatever term you want. Right here, I search by term loop. You can search by policy statement. And it highlights all of the details. Right? If you need to find some other artifacts, you can always do this. So general feedback so far from our customers has been, we're putting all of the collected source data, configs, and state at their fingertips, and they can really quickly find this. All right, but let me carry on with the...
Quick question.
Go ahead.
Can you correlate this with other information from other systems? For example, BGP notification down, and then can you schedule it to pull from the device what's going on?
Yeah, so if I can paraphrase your question, how external events correlate to data collection or snapshot creation here. And of course, you can ingest in your workflow whatever the data sources you have and invoke REST API call to our system such that upon event, it will proceed to collect some data. All right. So I would like to cover that application team self-serve because it seemed like it draws some of the attention here. That's really interesting. And it's really one of the primary use cases in Forward Platform. So in order to do that, let me switch to this view here. Here's what happened. And this is coming from one of our customers, Global Payment Processing Company. They have an application delivery team. Let's call them app guys. And those app guys were constantly frustrated that, hey, at a given time, when I'm trying to deploy an application, I need to know whether the network supports it. It's a very basic question. I need to know whether A can reach B. That's all they wanted. And in the absence of something like that or other systems, they had to open tickets, support tickets. And those tickets have been piling up in a long, long queue and taking very long to address. So what happened? Network guys, network operations team, they decided to give them something that allows them to be some self-sufficient. So the way how they envisioned this is, hey, I would punch in the query where I would say from A to B, and the application guys would say, is it pass or fail? Right? If it is failed, the network operation guys would want to know what doesn't work, why it doesn't work. And so I took their use case, and of course I cannot use their snapshot. We don't have that snapshot. In the demo snapshot, I translated it and implemented it in a more simplified way. But in a nutshell, I want to know how traffic would traverse from client application to server application. It further gets complicated because at the time when I'm asking question, I don't know where either of those are located. So let's see how it works in practice. So here I would say from host to 10.5.0.130 on destination port SMTP. And what you see right away at the bottom here is so-called day in the life of a packet, right? We're all used to that terminology. So as you see, the traffic ingresses on this NSX distributed virtual switch and hops over the VXLAN tunnel to the other distributed switch, hits the edge to get routed out of the NSX domain, and so on and so forth. But I want to draw your attention here to a real quick thing. These two locations for one and the other distributed switch are in different data centers. And they're linked together via that VXLAN tunnel. So this is another problem that we have been hearing some feedback on. It's really hard to troubleshoot and correlate overlay to underlay, right? Because it oftentimes involves whiteboarding or scribbling on a white paper or a piece of paper. For a Forward platform, you simply click on underlay, and it will provide you with complete path analysis of how traffic could start from one VTAP and traverse to the other VTAP with all of the details in transit, such as Do I have any MPLS where it's pushing and popping and swapping labels? What are the ingress-egress interfaces? And you can even click the C device state, and it will bring up a specific entry from the routing table of that device and tell you exactly why and how this happened.
Can I interrupt you for a second? This is awesome.
Yeah.
I appreciate the feedback. Thank you.
Thank you.
Can you export this information?
We can export this, absolutely. This data can be retrieved via API.
Can you just go back to that picture, DC data center interconnection, when you clicked on underlay? So when you click on that link, I think.
On this one?
Yeah, underlay.
Yep.
Okay, normally it shows just between the two data centers?
No, what it would show you is how to get from one VTAP to other VTAP. Their location is irrelevant in this case. Well, in this case it is because they're in different data centers. It can be within the same data center on 2 racks. All right, but I digress. Let me go back to this application team self-service use case, right? So what we see the rest of the path is that, yep, I can see how traffic is getting routed, and whoops, look at that. Firewall is dropping traffic. But guess what? Network guys are like, yes, it's not us, it's the firewall team. But the net effect here, the app guy is still frustrated. Their stuff doesn't work. So, I mean, look at this right side, right? We're telling you that there's an access list to AWS default deny that is denying traffic to this traffic. Did I have to be a firewall expert or know anything about that firewall at all? No.
A little bit networking knowledge required.
Yes, absolutely.
You have to be able to read the right-hand side of the screen and understand what it means.
So if you really wanted to correlate what it is doing in the gut of that firewall, you can click on C device state, and it'll show you this is one security zone, another security zone, and here's the rule or policy that is applying action deny. So one might say, perfect, so this is actionable. I can give it to firewall guys, right? And they will fix this, add exclusion or exception, and things will start humming along. Not so fast. Well, so we're talking about enterprise with elaborate security policies. They have multiple layers and perimeters of security. You bet there will be multiple firewalls between the source and destination. Now, if only we had a way to temporarily ignore presence of the access list and move into this predictive nature, something like, what would happen if this firewall wasn't dropping this traffic and simply tried to route?
So what if?
What if?
Okay.
Precisely. So, and we got you covered with permit all mode here. Click on that, and now you can see that this is the firewall that was dropping before, and instead now I see it's ignored in permit all mode. But look at the diagram. Wow, look at that. It's actually going all the way to AWS. So now, remember I alluded to the fact that there may be more than one firewall. Let's see if I was right. Firewall here, and it's traversing through MPLS, and wow, there's another firewall. Again, it would have been dropping, but we're ignoring to make sure that we now can answer questions for network guys. Does the network function correctly? Yes, it does. How do I know that? Well, look at that. Layer 3 function. It's routing it to default route, and there are 2 next hops, ECMP. Right?
So effectively, when you go into permit all mode, you can identify all the firewalls that the packet would hit in the path based on the current routing state, and it would tell you, oh, no, you don't have just the problem on this firewall, you also have a problem on that one, and that one, and that one.
Yes. I mean, we can swap seats, you can present.
That was exactly the use case. That was exactly
the use case.
The use case. They wanted to know all the firewalls that they needed to touch to enable this flow to go through.
Yeah.
Can you make somehow this visual, all the firewalls that are in the path?
Yeah, so this data, again, can be exported as JSON, and that's precisely the use case that one of our, that customer is driving. So let me quickly summarize this, because there's quite a bit of content.
But while you are doing what if, you are not taking any action, so you are not changing any firewall rule?
No, we're not changing. We're simply saying, what would happen if this firewall wasn't dropping the traffic?
Yeah.
All right, so this data that you see here, and by the way, this traffic it ends up in VPN, in AWS VPC. So this is hybrid infrastructure where it starts in your NSX, traverses through a data center, and ends up in Amazon. So this data flow at the bottom here is actionable. You can take this, pass it along to the firewall guys, and now they will say, oh, okay, I have these 2 points where I need to make the change. So the net effect for that payment processor company was that the support queue tickets shrunk significantly, because now network guys are really working on some really significant problems. App guys are happy, their questions are answered quickly and in self-service manner, And the network guys can focus on the architecture improvement and growth of the network.
Can I get the latency information between these two flows?
So we do not collect the latency information. There are some ways to correlate latency from external data sources. If you want to learn about that more, we're happy to discuss that with you.
I have another question. It's great that you have that, yeah. Just an additional problem that I'm facing a lot is MTU, yeah. So a lot of problems.
Ooh, I got you covered.
Yes,
A little later,
I
I got you covered. A little later, if time permits, I will cover that. So let me get there.
Okay.
All right, so the next use case comes from another customer. And for that, I will simply switch to diffs application. So I can select before and after snapshots. And what we're doing, we are showing you for a variety of categories of diffs, right? What has changed from one point in time to another point in time. And so why is it important? Whenever you change window, once you get out of it, it's very important to answer two questions. Number one, what has changed? I mean, you know what has changed, or at least
hope you know.
At least the change management, the operation procedure tells you that, hey, you're going to change that, and those changes will occur, and this is where you need to check things, right? That's one. What has changed? Number two, which is a lot more harder to do in practice, is has anything changed beyond intended scope? So I may have wanted to do something, but something else has happened. Let me switch to the slide real quick to show you, to illustrate the point. Again, this comes from the customer use case, but I simplified it a little bit to make the point to illustrate it here.
Just a quick question. Can you do the reverse modeling where you have an intent and you can, for example, apply a certain configuration and you can push it down to see what the net effect is going to be?
So short answer, no. Long answer, we do not push anything.
But I'd like the virtual graph. I don't want to push it down before I commit to it and actually do the verification. But I could maybe use your tool to see what is the result if I do this.
Mm-hmm. Yeah, so there's a limited subset of...
Network-wise, what if analysis you are talking about?
What?
Complete networking, entire network-wise, what if analysis?
Yeah, I want to see if...
So we can do what you're asking within the scope of changes to access list, NAT, and firewall rules.
Okay.
Yep. So for the data.
Remember that they're reading state of the FIP.
Sure, yeah. Sure.
So if someone else can't compute the state of the FIP.
Yeah.
All right, so this use case, we have a standard three-tier architecture, right? These are routers, and what has happened here is on the distribution device at layer 2, layer 3 boundary, they have changed the IP address of SVI from, and please pay attention because this is important for the next step. The 190.0/24 was the older IP address, and it changed to 196. What should happen? The router will make routing advertisements, and they will propagate throughout the network, and everybody else should do the two things. First, delete the older route, 190.0, and install the new one, 196.0/24. Let's see if that happened. Well, actually, yeah, it's going to be, well, let me show you. Right? There you go. So in order to do that, yes, you can take a comparison behavioral diff between two snapshots, before and after, and we'll show you a variety of things like what devices have been added, maybe topology links went up and down, configs, of course, this is standard table stakes, what has changed in the configs, but it's a lot harder to do behavioral analysis. Because now we're not just looking at the text output of the data, we're analyzing changes in the behavior of each device. And then we're comparing the two behaviors, or the fingerprint of the behavior, between two snapshots. And for the specific use case, I will just switch to IP routes. And I see here that I can answer first question, what has changed? Right there. You see some routes were added, some removed, some modified. That's first answer. Now I need to verify that actually it checks out. So my distribution router sees that there's a removed route, 190.0, just as I expected. The new route in Corp extranet VRF has been added, 196. Same things or similar things should register in the upstream routers. Let's see if it happened. The CE here is actually the router where this should have happened. And now I see that there's Corp extranet MGT tools, and just to illustrate the point, modified is when, let's say, I have the next hop has changed. So you don't have to really scroll through tons of data. It just shows up here. If you want to see the factual output of data here, before and after state, and you see that the next hop has changed,
But let me go back here. We are interested in the context of corporate extranet. Do you see the issue right away?
That's 22.
That's one. And
The
older
removed one.
Huh?
The removed one.
Where's the removed one?
Okay.
So the old one wasn't removed, and the new one was installed with /22 instead of /24. Furthermore, this interface here, it is pointing to the firewall instead of distribution route. So let me cut it short. This problem occurred for them in a change window. They have been able to revert because they've seen this happen in forward platform. Effectively, they black hole traffic. Because for /22, they were pointing to the firewall, and firewall would have been dropping because there was no rule. After root cause analysis, turns out it was the problem with old remnants of route summarization policy that was implemented for security. All right, so let me quickly summarize. I hope this illustrates the point how you can use diff application, behavioral diffs, during change window to assist you as an engineer and get you a lot of power. So feedback so far has been, we show all the details of what has changed in one single pane of glass and bring all the power at your fingertips.
But if you didn't remove /24 and edit /22, still longest match would win and /24 would be pointed out.
Yeah, so it was a really, I mean, again,
well, it's a made-up example a little bit. Yeah. Don't go into the
I made
data.
this for illustration
The point
purposes.
is that you can look at the routing table and see that you don't see the expected changes.
Yeah, so the problem is that in real world, if you wanted to check this, you only go by what is in the map typically, right? And the map says, you change it here, verify over there, and over here. Okay. But what happens, it traverses throughout the network. And we will tell you all the places in the network where it has changed.
But this also means that you can, for example, after any software upgrade or hardware change or anything, verify the routing tables in the top of rack switches.
Yes.
And you see that the fabric still has the same connectivity it had before.
In fact,
or if you are migrating from one protocol to another one.
Gentlemen, I mean, absolutely.
We are stealing your show, yeah.
Yes.
We got them back.
No, I don't have to say this. You already said it. Thank you. It's exactly what's happening. All right, so...
And you can look back. Basically, you have a snapshot on every day. Somebody's complaining last month on Thursday, this started happening. You can take a look.
You know what should be one of their use cases? Forensics.
Yeah.
Right. So, gentlemen, I would like to cover a small topic. It's a huge topic, but I don't have too much time for that, so I'll cover it quickly. The MTU mismatch, right?
Okay. Can I just ask you one question before you go there? So that with the routes were great, but imagine I actually know what I'm doing, and I know that this server should talk to that server on MySQL port, and someone actually took time to write down all the rules of who should talk to whom. Can I use those as unit tests and run them through your platform?
I was just going to show you that.
Okay, thank you.
I was about to show you that. Yeah, so, yeah, we didn't pay him, so, for the record. So the thing is that, listen, the real big problem, right, is that when outages happen, the root cause analysis and postmortems happen. The network engineers, they are, and not NetOps, they are tasked to make sure that this doesn't happen ever again. Right? We have a library of things that have caused in the past business impacting outages. And we group them by different categories, like BGP related problems, sanity checks, high availability, etc. So these don't apply to everyone, but whenever it does apply to you, you can simply click a button and it will verify whether the router ID is your loopback IP address across the entire network. So other things that really fascinate me are things like forwarding loop. With simple click of a button, you can find out if you have any forwarding loops. We didn't have to look at any factual traffic. We don't have to. Remember point number 2, we don't observe real traffic, right? We did this because we have mathematical models.
Is this permanent loop or micro loop we are talking about?
It's any kind of loop that may potentially cause outage, and you may or may not know about this.
It's a forwarding loop at the time they took the snapshot.
Yeah.
Thank you.
Period.
Loop is the hard case.
So the MTU mismatch,
When they took
MTU problems that you mentioned earlier, we have a pretty fine check for that. So we see that there's failure. And in this specific example, we see that one side is 1500, the other 9200. We will flag all of the MTU mismatches across your entire network, right? And yeah, so we will give you all the power for that data.
But this would be the interface MTU mismatch.
That's right.
What he's really asking for is can you compute the end-to-end MTU of a path?
Yeah, so for example, you can read from the config, there's a VPN tunnel, yeah, okay, there's an additional header. So can you somehow extrapolate that as well?
So can you do PetM2 discovery?
Yeah,
So-
so that's a request we have received. It's something that we plan to implement, soon. But it's something that we could, get from the model.
As we have the data, I think it's also a great use case. Yeah.
Absolutely, and we're happy to discuss with you some more details about that specific use case.
Or MTU may be causing your
Yeah,
SPF.
we are living in the header hells. People are doing GRE, VXLAN, and whatever. Yeah, so payload is getting smaller and smaller.
Yeah. All right, gentlemen. On that note, I would like to hand it over to my colleague Andreas. Andreas.
All right, thanks, Elyor. So we just saw these predefined checks and checks, and now I'll show you about how we can define custom verification checks using Network Query Engine, which is this open config data model that we mentioned earlier. So, but before I dive into that feature, let me just tell you about a large service provider that asked for our help with a pretty interesting problem. So in this setting, the service provider has two networks, a downstream network and an upstream network, and they both belong to the same service provider, but they're managed by different groups within the service provider.
So different AS?
Yes.
Yes. And they're both rather complex networks in their own right, but for this case, we only need to focus on this pair of BGP routers. So there's a downstream BGP router, D, upstream BGP router, U. D is advertising routes to U, and U's job is just to distribute those routes to the rest of the world. So that sounds like a simple BGP use case. What could possibly go wrong here?
A lot. A lot.
I mentioned BGP. So, okay, so basically a lot of things can go wrong. In particular, one thing might be import policy. So this upstream router might have some import policy that the downstream guys are not aware of. So for example, you could have a filter on a community value, or you could be filtering routes based on AS path, or you might even have a static route up there. So some leftover configuration, for example.
Like maybe someone is doing lots of prepend and upstream guys is just filtering.
So maybe D is not aware of these details. Actually, the upstream guys might not know either. So when D starts innocently using this community, at that point, its routes get filtered and traffic stops flowing to a destination. So that's obviously bad, but it gets worse because in this network, there are actually two pairs of these BGP routers. One is active, one is backup. The backup doesn't carry any traffic. So if you have this configuration problem at the backup upstream router, you may not notice it for a long time because it doesn't impact traffic. You only see it after a failover.
Been there.
Yeah. So, this being a service provider, there are SLAs, and so this is expensive when this happens. And I've simplified the problem, but it is real. It's not just theoretical. This has happened to the service provider in the past. So it's a pain point for them. Okay, the good news is that the operators have found the root cause of the problem, and they have an idea for how to proactively detect this problem as soon as it happens in the future, possibly before it causes an outage. And the solution is very simple. It's grab the advertised BGP routes from the downstream router, grab the IPv4 fib routes from the upstream router, and just check whether all the advertised routes are installed upstream as expected with the expected next hop. So this sounds great. So we asked them, what are you waiting for? Why don't you do this? And they explained to us why this is harder for them than it looks. So practically speaking, this network design is replicated many times over. They have hundreds of these BGP routers that they need to do these checks on. There are modern APIs like netconf and BMP that would make this easier, but the support for these is pretty spotty. So some devices have it, some devices don't have it. Those devices that have it might not export all the data that you need for this use case. And so they were faced with doing upgrades, software upgrades, and given the number of devices, that just would take too long. So the only realistic alternative was to fall back and do some CLI scripting. So grab state from all these devices, parse all this state, these vendor-specific files, build a common data model. And developing that and maintaining that over time is just a burden that,
Are you
was giving
looking
them
for the BGP agency RIP-in database here, or just a global BGP table? That's
So-
important one, because BMP would look at the both.
Yeah, BMP would give you both. So
Yeah.
we want the announced routes from the downstream, and it's also useful to get in received routes at the upstream.
So you can
in
get-
that case, it might be.
So you're looking into out RIP
yeah.
Not agency RIP.
and the main RIP on the receiving end.
Yes.
Okay.
Okay, so that's the service provider story. It turns out this is not isolated. We've actually heard similar stories like this before from other customers. So another customer wanted to do just a handful of simple checks. So interfaces, BGP session, just simple checks. And because of the network complexity that they were dealing with, this was many thousands of devices, hundreds of different software versions, this turned into a mammoth project. So they estimated they'd have to put an engineer on this project for 6 months to develop these rather simple checks. And 80% of that effort is just getting the data. That was their estimate. So Forward Network Query Engine is trying to remove this burden and providing our users with access to structured, normalized data about their network so they can focus on the high-level aspects of their use cases. And the reason we can do this is because we already have all the data. We've put a ton of engineering effort into making collection, parsing, and normalization reliable and efficient across a huge set of devices. And so it's the bread and butter of our platform, and it powers all our applications. So in effect, what we're doing with NQE is just taking that data model and exposing it in a convenient way for external applications. And so what NQE does is it takes in we've got all these vendor-specific files, and we organize them into the structured normalized data model. And when I say structured, I mean that it's fully parsed. We're not just taking text output from a device and putting it into a string and then letting you, go into it, which I've seen before.
Yes. And it's called netconf.
Right. So it's fully parsed. You don't need to write any more parsers at this point. It's normalized, meaning that the data is represented the same way uniformly to the extent possible across all devices that we support. So for example, interface data will look exactly the same on a Cisco router as on an A10 load balancer and a Palo Alto firewall. It'll just be all uniform. And then we've added a query API on top of that. So that lets clients ask for specific subsets of the data that are of interest. So a client can come in here, for example, and just ask for, I want interfaces and administrative status and operational status, and get just that data. So basically, with that, you can essentially sort of query your network as if it were a database. You send a query and get data about all information across your network.
And I guess you're using REST API, so I can write the queries as JSON queries and run them once a day.
It's even better. So we're using the query API is based on GraphQL, which is a fairly recent technology. It was open sourced by Facebook in 2015. And it's gained a ton of industry adoption since then. And there's a lot that could be said about the topic, but I just want to focus on a couple things that it gives us for NQE. So GraphQL defines a very simple schema language that we can use to describe the data set. That schema language is essentially objects and fields. It gets a little more complicated, but that's the main point. It's objects and fields. And then the query language is very simple as well. You basically write down the fields of the objects that you want. It doesn't even feel like a language. It's more like JSON without any values. And then the response that you get back is basically JSON with the values filled in. So you get exactly the data that you asked for and nothing else. The query determines the answer. So this is very easy. The results should be easy to use in any mainstream programming language. Okay, so with that background, I want to jump into solving this service provider's problem with NQE. And just to remind you, basically what we're trying to do is check that all the advertised routes from the downstream router are actually installed in the upstream router's fib. And so to do that, we need to write two queries. One query to get the advertised routes, and one query to get the fib from the upstream router. And then we'll put it together in a little Python script to find the violations. And I think you'll see it's pretty easy, and I'm hoping that I can actually get you guys to help me write this query, even though you've never seen GraphQL or this data model before. So let me jump in here.
While you do that, just a quick question. On the configs that you grab, put you everything of that config into the database, or is this partially just the pieces that you need for your model?
He didn't hear the question.
Let me just log in here. OK, great. Sorry, can you repeat that?
Do you put in your database just the whole config that you grabbed, so all the fields, or it's partially selected so that it is fitting your model?
So we parse a lot of data out of the configuration and state. Not all of it.
Not all
of it, but we parse a lot of it, and then some subset of that is actually exposed via this API. And that subset is growing over time. We'll add more and more. So there's more within the platform than we've exposed right now through this data model. Put it that way. And that's
you have
growing over
already
time.
normalization for some parts of the config that you even not use at the moment, but maybe you have future use cases, and then you have the data already.
That's correct. Yeah. So what we do here, we try to really optimize what we deliver. Right, so if some of our customers or prospect customers ask for a specific field, we are going to add it. We are going to be very strategic on what we add and what we wait to add later on. So.
Okay, but to build on that, in OpenConfig, for example, you have the configuration of the device, like BGP neighbors, policies, yada, yada, and you have the operational data. Operational data you can get from show commands. For the configured state, you need to parse the configuration. Are you doing that? And can I get like Cisco iOS BGP configuration in OpenConfig format?
So we're getting both configuration and state. And I think that we are basically, they applied in OpenConfig terminology, they differentiate between intended configuration and applied configuration. So we're just applied configuration. So this would be everything that's in the state elements of OpenConfig models. It's aligned with OpenConfig. It's based on OpenConfig, but it's not literally, the results that you get back are not 100% compatible with OpenConfig. In the sense that it's not an IETF and JSON encoding of OpenConfig data. So we've made some changes. You'll see in a little detail. OK, so here's a snapshot to illustrate the problem. We've got a Juniper router down here, this MX01. This is our downstream router. And then we've got our Cisco router up here. This is called N3K01. And so MX01 is advertising a bunch of routes up here. And then we've got some of these bad policy up on N3K01. So to look at this via GraphQL, via NQE, we can click down here on this GraphQL link. And this brings up the Network Query Explorer. And this basically is a tool that allows you to try out queries and explore the data model quickly. So on the left-hand side, you've got a query editor where you can write your query. In the middle, you've got a results pane, where you see result of query execution. And on the right-hand side, you can explore the schema. So this is showing us the root object of the hierarchy is this query object. And inside the query object, you've got one field called devices. And its type is a list of devices. And within device, you can drill in further, and you can see that this has a bunch of fields like name and platform, interfaces. Interfaces, in turn, is a list of interfaces, and you can drill in further and further. And in general, we have commentary, informal commentary throughout the schema, as well as formal types. So this is just built straight out of the GraphQL schema that we expose. So coming back to this query, this default query here, so this is asking for the devices field, the name field of each device, the name field, the platform field, and from the platform, the operating system. So we can go ahead and run this. And actually, I ran this on this is the wrong network. That was the demo network that Elyor showed. So here's the actual our network. So we see our two devices, MX01. Okay. So now let's try to write this query that grab the announced routes from the downstream router, which is the MX01. So the first thing I'll do is actually limit the results to just MX01. So we can type in here and filter by the device name. So now we're limiting to just MX01. Good. So now we need to get those BGP announced routes. So here, we can just start typing and see, well, which of these fields make sense? Anybody want to guess?
Oh, name.
BGP rib. Name. This is not the obfuscated version. All right. So inside BGP rib, we've got BGP rib is organized by address family. So we've got AFI-SAFIs. And we can look at, there's AFI-SAFIs. So this is the way I usually develop, just iteratively going through these queries.
So just if I want specifically 1.4, let's say.
We could specify. Yeah. And then within there, we've got neighbors. And within there, there's lots of stuff. So we get our neighbors. Now we want the upstream. We want the routes announced upstream. So I can limit this to this specific neighbor, 10.0.1. I happen to know that's the upstream routers address, so we'll limit to that. And now again, we'll go in here, and now we need to get the announced routes. So we've got a couple choices. And this one looks pretty good. Add rib outpost.
So you have the in rib and the out rib.
Yeah.
So you could effectively, even though the routes are not in the forwarding table,
Yes.
Yeah.
because this is the backup path, you could check the in rib and say, yeah, it's receiving them,
Yes.
and when they are needed, they will be installed.
Yeah.
Cool.
So they are there, but before the filter. Yeah. Not maybe backup route, but before the filter. But they are costly for the memory anyway.
Yeah. So there's a couple. There's adrib in, pre, post, adrib out, pre, post. So right now we're only exposing adrib in post and adrib out post. So adrib out post in post is post filtered, received, but not necessarily selected.
So is the main rib by neighbor?
Yes.
Yeah.
So within adrib out post, we'll get there's a page of routes. So in general, there can be a lot of BGP routes. So we page the routes. So you ask for one page at a time. Now in this snapshot, it's small enough that all the routes will be returned in the first page, so I'm going to ignore that detail.
If it's DFC then, so like full internal routing table, then what we will do? 750,000 prefixes.
Yeah, we can page them.
Yeah, you page them. So you ask a series of questions like you might ask. Well, you can ask for specific prefixes, routes, or you can ask for, give me the first 10,000 routes, give me the next 10,000 routes, give me the next ones.
Based on ASPath, can I look?
Exactly. Can you filter per ASPath or
ASPath.
You
community?
cannot now. But that's something that we can add. So we can add filters.
That
would be cool.
Yeah.
Cool. Otherwise, so much in DFC,
Yeah.
default free zone, so yeah.
Well, you can pull out everything and do the filtering yourself, but why?
Yeah, absolutely.
great
So
to
I
see
fully
here.
expect we'll get a lot more filters over time as we see how this evolves. So within items, we'll grab prefix, we'll grab the route attributes. We'll just grab one, just the AS path. And let's see, AS type and great. So I'll run this query, and now we've got all these routes. Great, so that's it.
Can I do
that's
this
our query.
for BGP confederation then? I saw AS sequence. So
What's that?
BGP confederation, can I do that?
If we can take that offline so that he can complete because we are running out of time.
Sure.
Okay.
I would like to show how easy to integrate that into Python.
Yep.
Okay.
Yeah. Okay, so the other aspect we need is we need that IPv4 table from the upstream. So let me just, in the interest of time, I'm just going to grab it. I wrote it out already. So let me just grab it. It's basically the same thing, but instead of going into BGP rib, you drill into network instances where all your abstract forwarding tables are. All this terminology comes from OpenConfig. So you grab the IPv4 routes here. Okay, so those are our two queries. We drop that into a Python script, put your couple queries here. Let me make it bigger. Don't worry about reading this. You don't need to read this. I just want to say we take these queries and we can just drop them into Python. A couple queries here. We have a third query here to get the received routes at the upstream. That turns out to be very useful as well. So then we run the queries, and we've got about 20 lines of Python code to actually do the checks. And then we run it, and we get all the violations. OK. So let me just wrap up. OK. So that's our custom verification check for the service provider. A couple lines of code, some simple queries. And so that's NQA.
So the point was really no parsing, no collection of all this data, and the ability for the user to write their own customized checks outside the platform. In the future, we may integrate some of these in the platform. The ability to write your own checks and have a library that lives within the platform is something that we are thinking about.
Thank you, Andy. Thank you, Elyor. So just in closing, 10 seconds, why forward networks? This is the voice of the customer. We have some very good reviews on Peer Insight and Gartner. I invite you to go for more details. We summarize a lot of things in 1 hour, so there is much more on our platform.